All right. So once again, 3.7 is modeling using variation. So let's look at the first one. Mm. All right. So for the first type of variation, we're looking at direct variation. It says y varies. So what end up happening is that you'll get a keyword or key phrase that will dictate how you set up your problem. So the first one, like I said, is direct variation. Y varies directly as x, or y is directly proportional to x, will cause you to use this setup. Y equal to kx, and k is the constant of variation. Excuse me. So k is your constant of variation. So that k, whatever k is, going to be the same or constant throughout your problem. All right, classmate just asked if anyone else hear a high-pitched sound. Please let me know if anyone else hear that, so I know if it's me that needs to change something. All right, I hear it. All right, hold on one second. Let me write this down, and I'll try to make an adjustment. All right, so I just put in another set of headphones. Do you guys still hear that high pitch? Somebody let me know in the chat if you still hear that high pitch. Okay, cool. Thank you very much. I appreciate it. Always let me know if y'all hear something weird going on. Thank you. Thank you. Appreciate that. All right. So, all right, cool, cool. Thanks. So it says the distance that a body falls from rest varies directly as the square of the time of the fall. If skydivers fall 64 feet in 2 seconds, how far will they fall in 4.5 seconds? Okay. So I'm going to give you a schematic as to how you can handle all of these problems in 3.7. If you handle them this way, you'll always, set yourself up for success. All right. So first step, identify, we'll say keywords. Let's say keyword setup. Let's go variation. So you want to identify the variation setup. Here is directly. So the keyword here is directly. So it's letting us know how we're going to set up our equation or our formula. So we know you're going to use this format because it's directly. All right, two, establish the variables you're going to use. All right, so let's go to it. The distance that a body falls from rest varies. So if you're looking at the whole phrase, varies directly as. And you go back to hit this, notice varies directly as. So what comes before varies is your y, or the first variable. What comes after as is your second variable, okay? So the distance that a body falls from rest varies. So the distance that a body falls from rest is your first variable. We can call it d for distance. It's up to you what you want to call it. Doesn't matter. But what you don't want to do is call it k. Let's say if you had kinetic energy. You don't want to call that a. It would be best if you call, k. It would be best if you call that maybe e for energy, because notice you already have k as a part of your relationship. K is your constant of variation, so you don't want to use k again. So just throwing that out there. And then it says varies directly as the square of the time of the fall. So we can call it t for time. All right. Questions on the variables. So now we can write the equation by using the variation setup and the variables that we have. And d came before varies, so d is where y is. And then we know we have to have k involved. K is always a part of all of these. And then notice it says the square of the time. So it's going to be t squared. So that is our equation that we'll use. All right. Questions. All right. So we have our equation. Now let's see. Write down. So let's write down the given information. So what's going to happen here is that we've established our variables, and we're going to have a distance, a first distance, and our first time. Then we'll have a second distance and a second time. And one of these will be missing over here in our second set of information. So in the first set of information, it says if skydivers fall 64 feet in 2 seconds. So the first distance is 64 feet, and the first time is 2 seconds. how far will they fall in 4.5 seconds? So time is 4.5, and we don't know the distance. And that's what we're trying to figure out. So this will always be the case. You'll have all of the information for the first set, and then you'll be missing one out of the second set. So now we can use the equation to find K. Our equation is D equal to KT squared. And we would take, I probably could have said use the equation, and that's the equation and first set of information. All right, so we'll use the equation and the first set of information to find K. So let's go back. D is KT squared. Go ahead and substitute D1 and T1. So that's 64 equal to K times 2 squared. So 64 is equal to 4K. And go ahead and solve for K. Divide by 4. Okay, should kept it red. K is equal to 16. Any problems with that? What step? That's 5, 6. Sub K. So now we go ahead and put K into the formula or the equation. So D is equal to 16T squared. Last step, find. Let's go use. All right, so now I use the second set of information and the new equation to find the missing piece. So T2 is equal to 4.5. So we're looking for D2. That's 16 times 4.5 squared. So that's 20, 25. Yep. And that's 324. That'd be feet. And that'll be the answer. All right, questions before we do another one. So that right there is the foundation of what you're going to be doing in this section. You need to, see the variation relationship, establish your variables, set up your equation, then solve for the missing piece, or solve for K, and then solve for your missing piece. All right, inverse variation. All right, y varies inversely as x, or y is inversely proportional to x. So instead of multiplying k times x, k will be divided by x. So you see that keyword inverse, and you will use this divisional setup. All right, this is a bunch of words not needed, so let me try to write down. No, but not everything. right, got one more sentence to write that gives actual info, but I'm gonna read this before I scroll up. When you use a spray can and press the valve at the top, you decrease the pressure of the gas in the can. There were a couple more sentences in here just explaining that process, but we didn't need that stuff. It says in general, if the temperature is constant, the pressure of a gas in a gas, right? Yep. The pressure of a gas in a container varies inversely as the volume of the container. And then next is where they write the info. So let me write that, then we'll get rolling. All right, so the pressure of a gas sample in a container whose volume is 8 cubic inches is 12 pounds per square inch. If the sample expands to a volume of 22 cubic inches, what is the new pressure of the gas? So I'll give you a chance to finish writing. All right, so first thing we want to do, like before, we want to establish our keyword or key variation setup. And so we see varies inversely as. So we're looking at inversely. That means we're looking at y equal to k over x as our setup. All right. I think the second step I told you guys was try to stay true. Yep, establish your variables. Try to stay true to what I told you initially. So our variables, if we look at what happens before varies, it says in general the temperature is constant. If the temperature is constant, the pressure of a gas in a container varies. So it's the pressure that we're looking at. So we can call it P for pressure. And then as the volume of the container. So we're looking at the volume of the container. So we can go V is equal to volume. All right. Problems with that. All right. Some of these steps can be done in any order, so that's why I'm trying to stick to the steps that I gave you. Looking at our equation, using our variables. So if that's the case, P came before varies. So it's going to be P equal to K over V, which came after your variation setup. So we're going to have P1 and V1 and a P2 and V2. So let's go back and see what the first set of information. So it says the pressure of a gas sample in a container whose volume is, so volume is 8 cubic inches, is 12 pounds per square inch. So the pressure is 12 and the volume is 8. For the second one, if the sample expands to a volume of 22 cubic inches, what is the new pressure? And this is our unknown. All right, problem with that. And I believe we should be at finding K now. Just like I said, I want to stick true to what I told you last time. Yep. All right, so let's find K. So we'll do P1, K over V1 in order to be able to solve for K. That'll be 12 equal to K over 8. We can solve by multiplying both sides by 8. Those 8's cancel, leaving me K equal to 96. So P is 96 over V as our new equation. Now to find P2, our second pressure, we'll go ahead and plug in V2. And that's 22, I believe. Yep. So that will reduce to 44 over 11, or should be 4.244. Excuse me. And of course, my math lab will let you know what they want, what form they want that answer in. Yep, I knew that was wrong when I did that. Should be 36. All right. Questions. All right, so let's do at least one more example. This next one combines the variations. So we do a joint variation. Let's see, do I want to do centrifugal force? Let's do this. All right, so combined variation is when more than one variation is used. So, in other words, if you use directly and inversely in the same problem, that's considered combined variation. Then the other one is joint variation. If you see the keyword joint variation, if it says or jointly, y varies jointly as x and z, then this will be the setup. Just multiplying x and z. It's very similar to direct variation, just that you're multiplying more than one variable or more than one element. And don't forget k is still involved. K will always be a part of these variation setups. All right, so let me write down a problem. All right, read the first part before I write these numbers in. The centrifugal force of a body moving in a circle varies jointly with the radius of the circular path and the body's mass, and inversely with the square of the time it takes to move about one full circle. And then here we're about to get into the numbers of 6 gram body moving. So I'll write more. All right, so a 6 gram body moving in a circle with radius 100 centimeters at rate of 1 revolution in 2 seconds has a centrifugal force of 6,000 dynes. Find the centrifugal force of an 18 gram body moving in a circle with a radius 100 centimeters at a rate of 1 revolution in 3 seconds. All right, give you a chance to finish writing and then we'll walk it out. All right, so let's look at what we have here. First thing we want to do is establish what are the keywords for our variation setup. So we see that varies jointly and inversely. So we have a combined variation here. So jointly means I'm going to do y equal to kxz, and inversely means I need to have something like this. All right. And of course, what x and z are and y will depend on our variables next. So let's look at that. Says the centrifugal force of a body moving in a circle varies. So centrifugal force is our first variable, and we can call that C. All right. So the centrifugal force varies jointly with the radius and the body's mass. So we want to use all caps we can. We want to use lowercase, you can, doesn't matter. Got radius for R, M for mass. And then inversely, with the square of the time. Then we'll do T for time. Questions, questions, questions. Make sure we're all right. So we know C is going to be on the left of the varies, or the first thing we write, because that was what was to the left of the varies. That's what came first. Now, next, after the equal sign, we know we have to have K. K is always a part of the process. Now, it varies jointly to the radius and the mass. Remember how we said we would write our jointly is this way? So it's going to be K times R times M, and then inversely to the square of the time. So the inverse part means I'm going to divide by T, and not just T, but T squared. All right, questions on that? All right, so now pull the info from the equation, I mean from the problem. 6 gram body, so that's your mass, with a radius of 100 and 2 seconds, 6,000 dimes. So write down all of our pieces. We got C1, R1, M1, and T1. So 6,000, radius was 100, mass was 6 grams, and time was 2 seconds. Make sure I got my numbers right. Radius 100, 6 grams, 2 seconds, 6,000. Okay. So now looking at the piece, the second set of information is going to have one missing piece. Find the centrifugal force. So we already know that our second C is what's missing. That's what we need to find out. And so we need our radius, mass, and time. So our mass is 18 grams. Radius is 100 again, and our time is 3 seconds. All right. So let's use this information to find K. So we're looking at C1 equal to K times, did I write? Oh, yeah, I did write R next. R1 M1 over T1 squared. So we plug in everything that we know. So this is what we have. 100 for the radius times 6 for the mass divided by 2 squared over there with the K, and then 6,000 on the other side of our equation. All right, so simplify that. Should be like 150. So 4 goes in 125, 625. Yep, that's what we have. So when you multiply this, simplify that, it'll give you that 150. Divide by 150. Is equal to 40. All right, so that is your new equation with K in there, and now we can plug in the values for R, M, and T using that second set of information to find the new centrifugal force. It was 18, it was 3 squared. Make sure I know I have 118, 3. Yep. All right, simplify that. 3 squared is 9. 9 goes in 18, 2. That's 200, 2,000, 8,000. So 8,000 dimes. Let me make sure. Yep. So the centrifugal force would be 8,000 dimes. All right. Questions. All right, so this closes out chapter 3 for us. So next class, the floor will be open for you guys to ask any questions that you may have coming out of what chapter 3 or whatever chapter. Doesn't matter, but whatever questions you have, the floor will be open for you guys to do that first. Some questions may be generated over the weekend after you sat in this section for a little bit, or some things may come up that you tried. There should be a review posted for chapter 3's test. So you can take a look at that, see if you have any questions out of that. That should help streamline and focus your studies to be prepared for the test. Then we'll be looking at chapter 4. Chapter 4 is our last chapter, and that gives us about a month to knock out chapter 4 and then review and get prepared for this final exam or final test. Questions before we close out for today and send you guys to the weekend. All right. So have a great weekend. Be safe. If you have any questions, feel free to let me know, and we'll go from there. See you guys on Monday.